Hello, my name is China Bouye. Today I will be describing the relationship between student academic performance, or API, and percent of teachers with the full teaching credential, known as full. Starting with the correlation, Pearson's R will tell us how strong the correlation is between API scores and full teaching credentials. So Pearson's R we can see with full, it's at 0.574, and the p-value is less than 0.001. So that's showing a strong correlation between teaching credentials and the students' test scores. The correlation plot. So this API has an even distribution, kind of like that bell shape here. And then the API in full is showing a positive relationship. So it's starting low and then it's increasing. And then the full here, full teacher credentials starting low and it's also increasing, working its way up. Linear regression. So this R squared, 0.330 or 33%. So it's showing 33% of the data. For the ANOVA, P is less than 0.1. So that means that this test is showing that it's statistically significant. Right, for the coefficients, we have model 0 and then model 1. So model 0 starts at 647.623 with no variables influencing the outcome. And then model 1 includes the full variable and starts at 185.505. When full teaching credentials increases, it'll go up by 5.66. And that P here is still less than less than 0.001. So here we have API mean test scores is 647.62. The standard error is 7.112. So the true population is within 7.12 points, making the data set accurate. And then for full teacher credentials, the mean is 84.55. And then the SE is, or standard error is 0.747. So this means that it's reliable with error only ranging about 0.747 points off. And then both is showing that the data is accurate. Marginal effects plots. So the plot is showing a positive correlation. We can see it starts low, it goes high, this gray around it. You can see that it starts a little bit wide here, but as it goes up, it becomes more narrow. So this is showing that schools with fully credentialed teachers have higher test scores. So here we have grad school broken up into three equal groups to predict the API. Category 0 shows the highest mean and standard deviation. So mean is 18.70, standard deviation is 5.91 for group 0. For group 1, mean is 5.167, standard deviation is 5.096. And then for group 2, mean is 2.358, standard deviation is 3.988. So group 0, highest mean and standard deviation equals a higher average score compared to group 1 and 2. There is a larger data set and some values may be higher or lower than average. Group 1 and 2 are closer to the average, showing less variation within the group. For linear regression, so model 1 explains about 44.8% of the data, showing moderate correlation. And that number, we get that from model 1, R squared 0.448 or 44.8%. For the ANOVA test, so P is less than 0.001. So that means that the data is significant. We could see that the amount of grad school influences test scores. The F statistic here is high at 220.6. So that's showing that all groups have a statistical difference from each other. For coefficients, so we have model 0, model 1, Grad school in three categories is a strong predictor of API scores. P is still less than zero point 0.001. Model zero, so when grad schools is at zero, test scores will start at 656.3. And then when grad school categories increase test scores, um, when grad school categories increase, test scores will also increase. And we can see that here. So starting low, and then it'll increase up here to about from 550 to 750. So grad school equals the percent of parents whose highest education is graduate school study. Low schools that have a low percent of parents that have grad school education, showing a lower API score. And then two, so that's more parents have a grad level education showing higher API score. Overall, there is a strong relationship between parents' education and the students' test score.